Hello everyone, I'm Nutan here. So today we'll be working on sklearn data set, which is data set Boston. So it is based on a value prediction related to property which are in Boston based on certain factors. And yeah, we'll be deploying a machine learning model and we'll be trying to predict. So let's get in. Let's import some libraries. And yes, I think you need Seaborn. So let's also import the sklearn model. So data sets, import uh, Boston load dataset load Boston. Yeah. So let's name it BS and there's no voice. So let's just check this. Yeah, now it's fine. So as we can see, this is the data points data, and this is the target. So also we have features names such as CRAM, Indus, CAS, NOx. So we can see the abbreviations given here. So crime rate. So this is the land zone. This is the proportion of non-retail business acres per town. So Charles River, track bound river. Okay, nitric oxide concentration, average number of rooms per dwelling. So tax, radial highway accessibility. So yeah, you can see these are the different features that is with respect to the data set. So okay, we have till L stat. L stat is percentage lower status of the population. So this is a target value or mean value of owner occupied homes in thousands of dollars. Okay, so let's dive into the data. So is the data, so ps dot data. Okay, let's just check one. Yeah, so there are around 13 values. So ps dot feature names. So there are, yeah, 13 column names as you can see. So let's make a data frame. P dot data frame. So bs dot data is the data. Then columns are bs dot feature names. So let's check for df. So we got the data. Df is null. Some. Yep. So there is no null data. Hmm. Let's check for bs dot target. So this is the target value. Okay. So let's just check if there's any null data. No attribute is null. Okay, we have to convert it to data frame. Mm, df target equals data pd dot data frame of b is the target. So the dot is null dot sum. Okay, as you can see, 0 0. So 0 is the column name. Let me just show you so there's no confusion. As you can see, 0 is the column here. So in the column 0, the number of null data is 0. Also, let's try to just see through the data. Mm, mhm. So describe the max is 88. So let's see. Okay, so let's see a correlation map. Correlation matrix. So df dot core ax equals ax PLE dot subplots. So this is to adjust the size 10 comma 10. Yes, and this is the heat map. Let's go with the heat map. And the data is correlation matrix, right? And ax equals ax because we have named it ax here. plt dot show not sure why, maybe spines. Ax is not defined. Okay, I think that is shouldn't be an issue since heat maps plots correlation to, yes, it should work. Not sure why map. Okay, maybe it's a nanot issue. No, but still it should work, isn't it? Yes, I don't think it comes here, in my opinion. I don't get it. What is the issue? Okay, I just checked a bit, so we have to mention fake. Yeah, so that should work. And by looking at this matrix, we can see some sort of a correlation between nitric oxide and Indus. What is Indus? Indus is proportion of non-retail business acre per town. In terms of domain knowledge, I'm not sure how is non-retail land and nitric oxide related, but we see some sort of a correlation over here. And also there's a good correlation between age as well with respect to nitric oxide again. So indecent tax. Oh, there's a high correlation between tax and red. What's red? Accessibility to highways. Okay, let's look at the data set. So, so this is okay. Let's see dot. So this is access to the highway. So 1, 2, 3, 4, 5, 6, 7, 8, and 24. Okay. 24 being the highest, and what is it, 5, 6, 7, 8, and then 24. Versus tax. Let's just see with respect to tax. Okay, starts from. Okay, let's just sort by. Okay, my bad. Or let's try to count. Okay, let's okay, that's not how it is. So anyway, we have from 188. So I see 711. So the values are in for every $10,000 of the property value. Okay. So if if it is near to a highway, the tax is more. That's a kind of correlation we are able to understand. So moving on, let's try to understand the target. Let's try to see how was it distributed. Excuse me. Okay, let's just try to remove this parameter and have a look. Yes. Here's the dot. Let's just try to see. That's to be on the top. Then go AX. Yeah. So we can say it's close to a normal distribution. We have some, for instance, here. Okay. Okay, alright. Now, since this is not a binary classification, as you can see, the values are varying. It's not in a 0 or 1. So it's not a binary classification or any sort of a classification. So we can understand that we can use a linear regression model, right? So let's split the data. Sklearn. So if train test split. So x test x train comma y test y train equals. So the data is df comma df target, and let's keep the train or test size to be 0.3. Let's keep a random state thing, random underscore, yeah, 0.3. Oh, sorry, I just, let's keep this 1 for now, and let's import the model dot linear model import logistic regression. The model equals logistic regression. So model dot fit x test y test. I'm sorry, it's x train y train. Okay, something was screwed. My bad. Okay. It's a white train. Okay. It seems fine, I think. Let me just restart and see. 'm not sure why this is happening. One 52. 52. Yeah, seems fine. Oh my god. What is wrong? Silly me. Okay, let's just try to change the random state and see how it works. 73, 71. So one seems better. Okay, let's try to predict and see how this works. So let's go to the data set, and also let's try to make another new data set. df1 is kpd.concat. maybe we'll have to mention the axis. Okay, wait, DF target. So let's just see. Yeah, we'll just do that. Yeah, so we'll add another column called target. Yes, the target is added in the df1. So we have df1. Okay, so we have df1. So we'll just note this down. As you can see, I'll just put in my data here. So that's the target value 36.2 was supposed to be. Let's do one thing. Let's just export it to Notepad to df1 dot getting JSON. So let's just go to a bit of documents. Mhm. Where is it? Where is it? os.chtr. Okay, I'll have to import os. Or I don't think I need this chtr. Okay, import os. Okay, current tree. C users, Gnote. C. Okay, so it's somewhere here, yeah? So what do we save it as? df1 which is an open with. So let's go with the notepad. Okay, this is the data set. So easy to read. Let's do one thing. Let's go with Excel CSV. CSV. Let's go with CSV. Open with. The reason I'm trying to open with WordPad is, yeah, it's very easy, you know. So data starts from here. As you can see, the prediction value should be 34.7 or something close because accuracy is 76%. And one more thing, it should be in a 2D array. 29.7. See, you will get an error if you try to remove this. As I said, it has to be a 2D array, as I said. So yeah, 29.74. That's a kind of, even though it's 34.7. Let's try this one. The value is 36. Let me just copy this whole thing. So the answer, the target value or the median should be this value. Okay. So yeah, I think there is a quite noticeable difference here, which is not that great, but let's try this one. Somewhere to close. Okay, 19.34, not bad. It's kind of great. It's doing the work. Let's try. Okay, let's go down somewhere or I don't know, something random. So it has to be somewhere around 30 or 28 or 26. 33, okay. As you can see, the 78% accuracy, so based on that, you're getting a value that's kind of closer. So that's it for now, and that's what we did.